Hey everybody, today we're going to talk about how to calculate pH of pOH and use those to figure out other pieces of information. For this lesson, you're definitely going to need a pen or pencil and some paper, and you're definitely going to need a calculator. You don't need a graphing calculator, but a scientific calculator sure does help, because that way you can see everything you're putting in. Just as long as it has a log function and a reverse log function, you should be fine. Alright, so today we're going to work on calculating pH. As we learned in an earlier video, pH is the measure of the percent of hydronium ion concentration or hydrogen ion concentration in a solution, as it says right there. Okay, so the pH is calculated using this equation right here, which I also have written down right here. So the pH is equal to the negative log of H3O plus, or the negative log of H plus. Either way, it's the same thing, because remember, hydrogen will mix with water to make H3O plus. Okay, so for certain molarities, this is pretty simple, and all you have to do is plug in the number. So, like for instance, if the hydrogen ion concentration is 6 times 10 to the negative 9 molarity, what is pH of the solution? You do pH equals negative log of 6 times 10 to the negative 9. So if you're doing that calculator style, you just do negative log 6 times 10 to the negative 9. Boom. So the pH of that guy would be 8.22. Okay? So that's how you calculate the pH of a solution. So you need the concentration of the hydronium ion concentration. Okay? That concentration is going to be molarity. In case you're forgetting what concentration means, whenever you have a box like that with something inside it, that means concentration of whatever's inside there. So like here means concentration of hydronium ion, here means the concentration of hydrogen ion, here means concentration of hydroxide OH minus. Okay, remember, a concentration is the amount of substance per volume of solution. So we use molarity, or moles per liter, for our concentrations in chemistry. All right, so molarity is the unit for concentration. So whenever you say what's the concentration of the hydronium ion concentration, then that's talking about what is the molarity of the hydronium ion in the solution. Okay, you can also do the same exact calculation for pOH. We haven't even talked about pOH, but basically it is the reverse of pH. It's the measure of the percent of the OH minus in the solution. Okay, so this gives us another equation, but really the real important one is the fact that since the pH scale goes from 0 to 14, if you add pH and pOH together, they will always equal 14. This equation right here is really helpful. Okay, so if I know the hydronium ion concentration or the hydroxide ion concentration, I can calculate the other three things: pH, pOH, hydrogen ion concentration, or hydroxide ion concentration. Okay, so in any solution, if you've got a whole number pH, the H plus and the OH minus concentration can be predicted without using the formulas above. For example, if I know the pH of the solution is 3, then that means the concentration of the H plus is 1 times 10 to the negative third. Since it's a negative log base 10, you just take the 3, put a negative in front of it, that goes on the power of 10, because that's how log base 10 works. Okay, so the pH is 3, that means the pOH is going to be 11, which means the concentration of the OH is 1 times 10 to the negative 11th. Alright? So whenever you have whole number pHs, it makes it a whole lot simpler to figure everything out. So if I know one of these, I know all the rest of these things. Pretty straightforward. Okay? Remember, the H plus and the OH minus concentration is only equal when it is exactly neutral. If the pH is 7, that means the hydrogen ion concentration and the hydroxide ion concentration are both 1 times 10 to the negative 7th. Okay? So when you're doing these calculations, the pH can tell you a bunch of different things. Okay? pH will tell me if it's acid, base, or neutral. pH will also tell me, is it a strong base or a weak base, or a strong acid or a weak acid. Also, if you're using any indicators, like for example phenolphthalein, it'll tell you the color of the indicator. For phenolphthalein is the example that I'm going to use, and phenolphthalein is in an acid, it's going to be clear. In a base, anything above an 8.0, it's going to be pink. Okay, so for example, what if I have something with a pH of 9? All right, let's figure out everything else. Well, since I know that pH plus pOH, let's go back up to the equations, pH plus pOH always equals 14, as this guy says. If the pH is 9, that means my pOH in this case, to add up to 14, is going to have to be 5. I'm going to use a different color than black so that way we see what we filled in. 5. Okay? So that part is pretty simple. As far as the 9 goes, remember pH and negative log base 10 are related to each other, so 9 equals negative log of whatever my hydrogen ion concentration is. Okay, so if you're going backwards here, what you do is you times both sides by -1 times -1 to get rid of the negatives here, times -1. So -9 equals log of hydrogen ion concentration. To get rid of log, you're going to do the inverse log, and the inverse log is you do second. Oh, sorry. So if I want to do the inverse log, I do second, and then I hit my log button, and that the inverse log is 10 to the whatever power. So I'm going to go 10 to the -9. So my hydrogen ion concentration is 1 times 10 to the -9th. Like we said, whenever it's whole numbers, so hydrogen ion concentration equals 1 times 10 to the -9. And that is molarity because it's concentration. So like we said, whenever it's a whole number, then it's just going to be that whole number 1 times 10 to the negative whatever that whole number is for the concentration. So with the 5 here, we know that the OH concentration is going to be 1 times 10 to the -5 molarity. Okay, so if the pH is 9, then that tells me that this is a base, because anything above 7 is a base. As far as strong or weak, remember we talked about in an earlier video, if it's closer to 7, it's going to be weak. So the pH is 9, it's only 2 away from 7, that is a weak base. And in phenolphthalein, a base is going to turn it pink. It's above an 8.0, so this guy is going to be pink, phenolphthalein. So that's a bunch of information that you can get just from having the pH or the pOH. Let's do a couple more examples just to make sure we understand. So I can find all that previous information from doing this. So if I have the hydrogen ion concentration, once again, I'm going to use the equation pH equals negative log of the hydrogen ion concentration if I want to find the pH. So in this case, negative log of 1 times 10 to the -5. So I already know that this is going to end up being 5, but let's just type it in the calculator just to be certain. So, negative log 1 times 10 to the -5. Okay, pH ends up being 5. And I knew that because it was a whole number 1 times 10 to the -5. Okay, so pH in this case equals 5. Okay. If the pH equals 5, remember, pH plus pOH equals 14. Oops. Plus pOH equals 14. So if one of them's 5, the other one's going to have to be 9. So in this one, pH is equal to 5 plus 9 is what my pOH is, equals 14. So pH equals 5, pOH equals 9, okay, which means if the pH is 5, this is a weak acid, and it will be clear with phenolphthalein. I'm not going to spell out all of phenolphthalein. So it'll be clear with phenolphthalein. Phenolphthalein. Alright, let's look at one that's slightly a little more difficult. Now this is not a whole number, so I'm definitely going to have to use the calculator to calculate it this time. And also this is the OH concentration. So rather than finding pH to start with, we're going to find pOH. But it's the exact same equation. Negative log of whatever the OH concentration. So in this case it's negative log of 9.2 times 10 to the negative 10. Alright, so we're going to take our calculator, plug that in. Negative log of 9.2 times 10 raised to the negative 10. Enter. So the pH of this guy is 9.036. So I'm going to say 9.04 is that pH. Or that is pOH, sorry. So if the pOH is 9.04, yep. So if the pH or pOH is 9.04, the pH is going to be equal to 14 minus 9.04, because together they equal 14. So 14 minus 9.04 is equal to 4.96. Okay, if I want to go and discover the concentration of the hydronium ion or the hydrogen ion, then I'm going to have to do 10 raised to the negative 4.96, which is the inverse log. So inverse log of negative 4.96 equals 1.10 times 10 to the negative 5 is what that comes out to be. Alright? All that other information, all the stuff about the weak acid and the phenolphthalein, the really important thing you just need for that is that. So this is a 4.96, so this is a weak acid as well. It's close to that. It's going to be clear in phenolphthalein. Phenolphthalein. Okay? So there's a lot of the information that you can discover from the pH and the pOH. Remember, if you have my notes, then the equations are on here, but it's the same equation for both pH and pOH, and remember when pH and OH are added together, it equals 14. Okay? Hope this helps. See you guys later.